Okay, office hours for worksheet 2.7. We actually did the first problem together the other day in the notes. So I'm going to go ahead and do these other problems. I hope you guys tried them all. I hope you guys, after the day 8 notes, went back and tried problems like number 8 and 12 and 15. Okay, so first step is we got to enter all these into our calculator. So this looks like the days of the month. It says October. So that gives us an idea of what our window should be when we go to graph it, probably 0 to 31. We want to go to stat, edit, and we have some stuff over here. The quick way is to hit clear on the top and hit enter. If you hit delete, you're going to lose the whole thing. So 1, 6, 16, 24, 30. And then 30, 68, 90, 32, 36. So this can be quick, but double check it, okay? Because if you get one of these numbers wrong, everything's going to be off. And you're going to be like, why? Because you put a number in wrong or skipped one or whatever. Mixed them up. Okay, that looks good. So after that, go to stat, calc, near the bottom, sign reg. If you're in list 1 and list 2, then you can just hit enter. Otherwise, you could select the list, second number 1, comma, second number 2. You got to put a comma between them. And the lists are in the upper left corner of the numerical keys. Hit enter. And this creates the regression. And I want you to write all this down, all of it. So we'll just write it down right here. Sign reg y equals a times sine bx plus c plus d. A equals 38.051990013. Now, some of you guys' calculators are going to give values that are slightly off, usually pretty close, but a little off. And that's one of the reasons you want to write this stuff down, because then I'll know that you were using a different calculator and that you're okay, that you entered everything correctly, because I'll know what the value should be, but it'll stand out to me. But it's going to affect all your answers a little bit, potentially. So I'm only putting answers on my worksheets and stuff that are for. So put that on there. Okay, that's the first thing to do. All right. Now, I should probably go ahead and get a graph of this. I'm probably going to use the graph for a bunch of things. So let's see. Let's go to window. We always go to window first. 0 to 31, probably. Percent of full moon is probably going to be 0. So I'll say -1 to 101. 0 to 100, but I like to kind of give myself a little buffer now. In reality, that's what should happen. Maybe our values aren't perfect, so it gets close. So I think that's good. Make sure you're in, like, if you're in degree mode, everything will be right, but when you go to graph it, oh, shoot. When you go to graph it, what's going on? Oh, hold on. I forgot to turn this off. And by the way, I haven't graphed it anyways. So turn this off, okay? But leave it there maybe. But it was giving me error because there's nothing in Y1. So after we create the sign regression, we go to Y1 and we say vars number 5 statistics equation reg equation, and it pastes it all in there really nicely. Okay, now we're going to go graph. Now I'm in degree mode, so I want you to see what happens. You're like, what? It's supposed to be like a sine curve, and it is, but it's like really stretched out, which is not what it should look like. Go back to mode, change the radian. You don't have to do anything else. Your sine regression equation was created for radians. In fact, it looks like it even goes over 100%. So I'm going to make my window a little bigger, 103. And I like to see the x and y axis, so that's why I put it at -1, but 0 to 31. So there you go. Now let's sketch that. I want to sketch of this. I don't need the scatter plot. I don't need a little stat plot. In fact, I think that's going to cause more problems. But just a quick, rough sketch. Okay, that's like about 100, 0. There you go. Quick rough sketch. Just so I know. All right, now it says at what intervals of time is the moon at least 3/4 full? Now, at least means greater than or equal to, and in this case, 75%, right? So what I'm going to do is I'm going to graph a 75% line and find this chunk of the graph. So this is stuff I want you to write on. This shows me what your strategy is. I don't need to see the buttons you're pushing and stuff like that. There's no work to show. That's what I want you to see. So I want to go y equals, we're going to put in 75, graph it, and then we got to find these intersections. Second calc, number 5, intersect, first curve, second curve. This is 31, so maybe is that close to like 6 or something? If you don't want to move the cursor over all day, it is 6.914697, comma 75. Now I'm writing these extra decimals in case I need to do some other calculation with this later on, which I don't want to find out I needed it and have to redo all this work. It's just easier to just write down now. First curve, second curve. This looks like it's around 16 maybe, because this is 0 to 31. Let's pass out. It's 18.143845, comma 75. Now the y value should be 75 because it's an intersection with that line. So there you go. Our answer in interval notation is 6.914, comma 18.143 brackets. Interval notation, I need units. These are days, right? Now, if you rounded, it'd be 6.915, comma 18.144. So that's okay also. There you go. Find the average percent of a full moon between the 20th and the 30th. So the 20th is somewhere around here, and the 30th is somewhere around here. And we want the average of the percents. So the trick I've showed you guys, this is mean value theorem. If you want the average, you find the area under the graph. Okay, this is a setup. I want you to show this, and then you divide it by the number of days, which is also the base of, if we flatten that out, we get a rectangle. If you divide by the base of the rectangle, you get the height of the rectangle, which is the average height. So we could do that here, or we could do this on the home screen. Home screen might be easier to do some math with afterwards, but we can do it here. Second, calculate number 7. 20 to 30, make sure we're on the sine curve. And it was good to identify on your little sketch where you thought it would be, so that when it happens here, you're like, oh yeah, that's exactly what I want to happen. If it ended up here, you'd be like, that's weird. Okay, so that's going to be 345.11958, and then we're going to divide by 10, which is kind of easy. We just say, well, that's 34.511958. But let's say it was something more complicated. Now, sometimes if you try and do math from here, it'll take you to home screen and successfully. Sometimes it can't. If I say divided by, oh, perfect. It totally takes me to home screen, and I can just divide the previous answer from the graph screen. Sometimes that doesn't work though. So the answer is 34.511% of full moon units. Okay, so if you rounded, 30.4.512. 3 decimal actually rounded truncated. Now, number 8 says, on what date is percent of illuminated moon increasing most rapidly? When is it changing the most? Now, on this picture, you could tell that's when it has the steepest slope. It looks like it's somewhere like around here. And it also corresponds to an inflection point. So the way I'm going to do this is I'm going to trick my calculator into graphing the derivative of this. So I go to y equals, and I'm going to turn off the 75 or just get rid of it. And then I come down here, I'm going to turn this back on, and conveniently it's in y1, so I don't have to change that to y2 or something else like that. And I'm going to graph it. Now, this is not going to work very well. I'll explain why in a second. But when I graph it, it's going to regraph the original graph, which is, cool to have on there. And then you'll notice something way down here getting graphed, which That's actually more visible than it is sometimes. But it's a lot smaller than the original graph. And the reason is that the vertical shift goes away. So usually the graphs of a sine graph that's been shifted the derivative will be back down on the x-axis. So we're missing parts of the graph that we might want to see. Now, we could do a quick sketch of what's happening here. Now, we expect the answer to be somewhere around here. And when we do this graph, you can tell it kind of looks like this. Like the highest, the steepest point corresponds to a peak. The steepest down point corresponds to a valley. But I want a better view of this graph. So what I'm going to do is I'm going to go back here. When I do this in the future, I'm going to turn this graph off, but it's still there. If you delete it, that's going to cause problems. Turn it off because we don't want to see it. We like the window for the x values, but we're going to do zoom fit. This will give us a nice view of just the derivative graph. It takes a little extra time because it's calculating lots of derivatives, and also zoom fit pre-calculates it all, so it's doing it twice. But just take this as a good moment to breathe, and then you get a beautiful graph of your derivative. And so that's just the derivative graph, zoomed in on it. And this is what we're interested in right now. This is the inflection point, the steepest derivative, and this is the max of it. So we're going to do second calculate maximum of this graph, and it looks like it's around day 6 or so. So I'm going to say, well, let's guess 3 to 9 and guess 6. You got to tell it where to look for it. And there it is. It is 5.5119288, 8.5177722. Now, the way we answer this, okay, you got to be careful the way we answer this. They said, what date is it happening? Now, they could have asked us, what is the rate when it's increasing the most? So we're going to say, the illuminated moon is increasing most rapidly at a rate of, now this is the derivative, this is the slope value, okay, rate of 8.517% per day on day 5.511. Day 5. I want decimals. I don't care if you're like, that's not a day. I don't care. 3 decimal accuracy unless someone else says differently. Okay, it's in the middle of the day that it's happening. Believe it or not, the moon's still there even in the middle of the day. Okay, so there you go. That's how we do it. So that's also, we're, by the way, finding an inflection point, location inflection point, which is not exactly what you're being asked. Okay, let's do the next one. So first thing, we need to enter all this information. So I'm done with this problem. So I'm going to turn that. Now go back and turn this off. Otherwise, it's going to be a problem for you. You might get errors, or it's going to slow you down for sure. So we're going to go to Stat, Edit, Clear. Don't hit delete. There's a way to get the list back, but it's just a pain. 7, 10, 13, 16, 19. Now, they're giving you 24-hour time. If they gave you AM and PM times, then you would need to change it to 24-hour time. Otherwise, it's going to confuse AM and PM and think they're really the same times, which they're not. And then 2.4, 0.8, 3.1, 6.5, 2.7. So double check it, make sure they're all correct. Okay, looks good. We're going to go to Stat, Calc, Sine Reg, Since they're in list 1, list 2, we could just hit enter, or you could type the list names in. There it is. Write this down, all of it. So sine reg y equals a times sine bx plus c plus d, a equals 2.877592541, b equals 0.51296866765. All of it. C equals negative 0.24540055762. D equals 3.174850196. So we got that. Now let's get a graph of it. So we want to go to y equals, and we want to get in here. So we're going to go y equals vars, number 5, statistics, equations, reg equation. Paste it in there. Perfect. Go to window. This is time in a day, 0 to 24. The values, I don't know. They might be 0. You could have negative height of a tide, right? So I don't know. We could go back and change this letter 0 to 8. Graph it. Yeah, looks pretty good. So there's our tide heights of the day. Let's draw a sketch of this. Just a quick rough sketch of the part of the graph we care about, 0 to 24. Okay. So now find the minimal tide height. Well, here's the minimum tide height, and here's maybe another one. They probably should be the same. And we could confirm this by finding both of them individually. So the way we find minimums, second calc, number 3 minimum. This first one looks like the first one looks like it's around 10 or so. So maybe we could go like 5 to 15, guess 10. It is 9.664896, comma 0.297257766. Okay, so write that down. Next one. Next one is second calculate, number 3 minimum. This one looks like it's around 22 or so. I'm going to say 20 to 24, guess 22. So that's way faster than going back and forth in cursor, just type some numbers in. It is 21.913571, comma 0.297257766. So now anytime you answer minimums or maximums, I want you to answer your question a certain way. And I'm hammering this home because it's going to be a big issue on your AP test. So I want you to do it in your sleep by that point. So we want to say the minimal or minimum tidal height is 0.297 feet units at time times t equals 9.664 and 21.913 hours. So I need all that stuff. I want the minimum and maximum value. I want the locations. This is the way to write it. Don't write them as ordered pairs. That will not get you credit. Okay, but you're showing me, there's not a lot of work to show. You're drawing sketches. You're showing me what you're finding. Find the terminals when the tide is at least 6 feet. So we're going to go to y equals and graph the line y equals 6. So let's see. Ooh, is it never hit 6? Is it barely hit 6? Now, what I think it could be interesting. Does it actually hit it? Does it go through it? So I think what we want to do is change our window. We see where it's happening there, but let's change our window to be right around 6. Let's say 5.5 to 6.5. So I'm really narrowing in on that. So there's our graph. That's the little peaks. And here's, ooh, it actually goes over it. right? Goes over it. So now I'm going to emphasize that on my little sketch right here. Here's the 6, and it says is at least 6 feet. That's greater than or equal to 6, so that these are going to be solid dots, and it's going to be this chunk of the graph. So you're showing me right now what your answer is visually. Now you just got to figure out what those numbers are and write your answer in interval notation. So we got to find these intersections. Second, calculate. Number 5, intersect. First curve, second curve. Now, these are so close to each other, I'm going to go ahead and use the cursor. We've got to say guess. So I'm going to guess to the left of this to make sure it finds the left one first. I'm going to write that on here. 3.1678142, comma 6. Okay. And then the next one, second calculate, number 5, intersect. First curve, second curve. Make sure I get to the right of that, but closer to that one, and it'll find the one on the right. 3.9133079, comma 6. And second calculate, intersect, first curve, second curve. Let's get closer to this one. So usually I like to enter numbers, but these are so close to each other. I don't know. It would take too much effort to type the right number. So I'm just going to go ahead and, okay. So I can calculate, number 5, intersect, first curve, second curve, get to the right of it. So, I mean, you guys should be really good at finding intersections of curves by now. 16.16198, comma 6. Okay, so the answers in interval notation are brackets, bracket 3.167, comma 3.913, bracket union, bracket 15.416, comma 16.161, bracket, what are the units? Hours. I need units, probably in all these answers. These word problems have units. Now, you could have rounded some of these. If you look at my solutions, it should have the rounded answers. But I'm generally not going to bother writing them. That's that. That has to say that. This could be 15. No, that stays that. This could be 16.162 instead. Anyways, find the average tide during 7 and 9. So 7 and 9 is like from here to 7 and 19. 19 might be like here. So the trick is this is called mean value theorem. We're going to find the area under the graph from 7 to 19, act like it's smoothed out. So now it's a rectangle, divide by the base of the rectangle, the number of days. So we're going to find the total tide height over 7 to 19 and then divide by the number of days. So I'm going to go back here. I'm going to get rid of this guy. I'm going to go back to my window and get a nicer picture. -1 to, I don't know, 8. So, or you don't have to do that. Do it from this screen. You could go to the home screen and do it. But it's kind of nice to see it, I guess, right now. So I can calculate number 7. We're going 7 to 19. It should shade it in. Right? It's kind of what we expected. Something like that. Gives you the answer. Let's go ahead and write that down. 38.1979994. And then we got to divide by 12. So we could say divided by, and it says, oh, you want to divide the answer from that calculation by 12? There you go. 3.183166129. Okay, so the answer is 3.183, and the units are feet, right? Round truncated through decimal, actually comes out the same. Okay, number 12, find the times when the tide is decreasing most rapidly. That would be when it's losing the most tide, the most height. So it happens at 2 different places. So what we're going to do, I'm just going to draw another sketch. That sketch is really full of stuff. And the sketch is to help me understand you're doing things right, just in case you get the wrong numbers. Now, we expect it to be here and here, and those are also inflection points, but decreasing would be negative. We're looking for a minimum. So we're going to trick our calculator into graphing the derivative graph. So I'm going to, and we could leave that on, And then we go down here and turn this one on, turn it back on, or retype it in. If we hit graph, it graphs it here. So we're kind of missing some of it, but it should line up. There's a peak around here, and then a dip should line up with that. And then there should be probably another peak that lines up here, and then another dip. That's right here. Now, by the way, these are zero slopes, so they should coordinate with x-intercepts of the derivative graph. Now, we could get a better view of this by turning off this graph, but leaving it there. Don't delete it. And then going back to window, or we could go zoom fit, and then it'll give us a nice window so we can see it. Because I think the minimums were off the screen, actually, which we wanted to find. We want to find this min right here and this min right here. Now, they should be, because this is periodic, they should be repeats, but we need to find both locations. They should have the same rates, the same slopes. So let's find those. Second calc min. This is 12. That one looks like it's around 6. So I'm going to say, let's do 4 to 8, guess 6. It's thinking. Everything takes a little longer. Okay, so let's write that down. That's 6.60274, comma, negative 1.476115. And then this one should probably have the same y value. Second, calculate minimum. This was 12. So this is probably maybe around 18. So we could say maybe like 16 to 20, guess 18. So I try and get my left and right bounds close, but give me enough room to be wrong and still find the answer. So this one is 18.851406, comma, negative 1.476115. No surprise, it's the same as that one. Now let's write our answer in a really nice way. The tide, and I want it with words, the tide was decreasing most rapidly at a rate of, give me the rate, negative 1.476 feet per hour. It's a rate. Change in tide over change in time. So you need 2 units. At times, t equals 6.602 and t equals 18.851 hours. I want units. I want a nice thorough answer. What was the max or min? What are its units? When did it happen? This is the safest answer. This will cause you to not lose points that people will lose if they don't do this. Okay? All right, last one. Moods, happy, sad, percent of best mood, I guess could be like 100%, like you're really happy, Of course, today you get tired, you get hungry, you have to take calculus. That makes you happy, right? So I'm going to go here, get rid of this, go down here, and just turn this off so I don't have to retype it because I like to use this a lot now. We're going to go to stat, edit. I'm going to go ahead and clear these lists. Now, if you created your sign regression equation, you can clear the list and still have the sign regression equation stored in your Y menu. So you don't have to have tons of lists in here. 2, 5, 8, 11, 14, 24, 8, 31, 65, 27. Okay, double, triple check it. Okay, so then we can go stat, calc, bottom list, sign reg. They're in list 1, list 2, so we can just hit enter. Thinking. Write this down. Y equals A times sine BX plus C plus D. A equals 28.77613712. B equals 0.512978924. C equals 2.3193433508. D equals 31.74857449. Write it down, all the digits, because I need that to help. Okay, now they give you a domain here that says days. So we're going to go to window. We're going to say 0 to 30. I guess we're thinking -1 to 101. If it's between 0 and 100%, maybe, potentially. Maybe she never gets to 100% happy or 0% happy. Let's graph it. Make sure you're in rating mode. Something's not working here. This is not good. Oh, we never put the equation in. Go to y equals vars, number 5, statistics, equation, reg equation, paste it in. Now graph it. There we go. Looks like a good graph. I mean, we could probably make the graph a little better. Looks like we can maybe go to 70 instead. I think it's worth it to maybe just get a nicer view of the graph. Let's draw a sketch of the graph. So the graph looks like that. 0 to 30, arrows. All right, so this is time, this is percent mood, best mood. Okay, so we want at least 60. So let's graph y equals 60 on this graph. Ooh, that's close, but it looks like it does go through it, right? But I really want a closer view just so I can make sure I select things right. So I'm going to go back to window, and let's say y min is 58 and y max is 62. So we're really focusing in on, see that? There's just the top of those peaks, and there's 60. Okay, so now I'm going to kind of exaggerate it on this graph because we don't need to make this look perfect because it'd be hard to see what you're doing. But we want to say at least that's greater than or equal to 60. So that's solid dots because it's or equals to, and it's above it. Okay, so I want to see that. And then we're going to find those intersections. Second calculate, number 5 intersect, first curve, second curve. Guess to the left of that. So that's 10.416372. And second calculate, intersect, first curve, second curve, guess. That is 11.162051. Second calculate, intersect, first curve, second curve, guess. 22.6648. And then this guy, second calculate, intersect, first curve, second curve, guess. 23.410479. Okay, so my answers are interval notation, of course, 10.416, comma 11.162, bracket, union, bracket, 22.664, comma 23.410, bracket. What are the units? Days. These are days. Okay. Average, I guess for the whole thing, right? So that's a mean value theorem. We're going to integrate the whole function to get the total percent mood, and then divide by the number of days, or the difference between these limits. So I'm going to go back and get rid of this, go back to window, and maybe do -1 to 70, I think is what we had. Get a nice picture of it again. Now I'll show you right now. We could just do this on the home screen. We go, and then we wouldn't have to worry about the graph. We go, here we go, math 9, vars, y vars function y1, comma x, comma 0, comma 30. And then you don't have to deal with the whole picture of the graph. It's thinking. Okay, so that's 890.8972268. And then we're going to divide by 30. Don't forget about dividing by 30. And we get 29.69657423. Okay, the other way to do it is to do it from the graph screen. Do so I can calculate number 7 and put 0 to 30. It's going to shade the whole thing. This takes a little longer because it shades it, which is cool, but not necessary. Gives you this answer. Oh, that looks pretty close to what we had, a little less accurate. And if you want it to be more accurate, just hit divided by, because that takes the whole number. It only displays so many numbers. It stores more numbers underneath it. Wow, perfect. Same answer. Okay. Now the answer is going to be 29.696% of best mood was her average mood. Okay. Date on which Siena's mood is improving most rapidly. The date. Well, that'd be when it's going up the most, there and there. So I'd say there's 2 spots. We got to find those. Those are like inflection points, right? So we're going to graph the derivative graph and find those max derivatives. Okay. Now, I mean, you could sketch it right now, like zero slopes are going to correspond to x-intercepts. And then the height, this is most rapidly, that's going to be a peak. And then coming down, that's going to be a valley, and that's a peak. That's a valley. So, I mean, I just sketched it without even drawing on my calculator. So I'm going to go to y equals. I'm going to go down here, turn this on. Now, we could just go ahead and graph it, but this graph could be, oh, shoot. This is not good because I can't even see it at all. Now, if it's doing it, there is a way to kind of get around it. You could do, if you try and quit, it won't work. You have to turn the calculator off, and then you can go back here. Now, turn it back on. Now, if we go to our graph, oh, there we graphed it. But you could do the whole clear drawing thing. So it's down here. Oh, there it is. But we're missing kind of some important parts of this graph. So what I usually do is I kind of pre-sketched it because I kind of knew where the peaks and valleys should be. But I would turn this off. Don't delete it because then you won't get a graph anymore. And then do zoom fit. And then that'll fit it to just the derivative graph that is left turned on. You need y1 still there so that the derivative graph can use it to make its calculations. If you get rid of it, then you can't do it. So there it is. So we're trying to find the peaks. I'm trying to find these peaks right here. They correspond to what we're looking for. This is what we're looking for right there. So we're going to do second calc maximum. And this is 0 to 30, so that's about 15. So that's around 7 or so. So we might say like 5 to 10. Nope, that doesn't work. 5 to 10, guess 7. I don't know if I did this right. No, I messed up. Second calc maximum. Okay, so we're 5 to 10, guess 7. It's good to know what your answer should be when you type something in wrong. So this is 7.7271007, comma 14.761551. Okay, we got to find all of them. Second, calculate maximum. This one, that's 15. This looks like it's around, I don't know, 18 or something. So I'm going to say 15 to 20, guess 18. Oh, shoot. If you get an error bound or dimensions or something like that, it means you guessed to the left or right of your values. So, okay. What did we say? 15, maybe it's around 18. So we could say like 15 left bound, 20 right bound, 18 is my guess. Takes a little while. Okay, so there it is. It is actually 19.975545, comma 14.761551. Now, if it gave me 20, then that means that'd be weird. Probably means I missed that peak. Plus, these should match up. If they don't match up, then something's probably wrong because we expect them. This is a sine curve. The peaks happen at the same values. So the date. So we're going to say Siena's mood is, this is the way I want you to write these answers, is improving most rapidly at a rate of 14.761% of best mood per day. Rates are two things changing. On days 7.727 and 19.975. Now, I already said days to begin with, so I don't need to say days after it. But this is the answer I'm looking for. This is the kind of answer I'm looking for. This is a nice thorough answer. It's going to help you not lose points on your AP test that you really shouldn't have lost, and not even on my test. So I require this to give full credit. Part E, you get to make up your own. I don't know, just create a scenario. Create some values, hours in a day, days in a month, days in a year, weeks out, whatever. Something that's changing. Create some values, fit a sine regression to it, ask a question, just one question, whatever. I don't know, just be creative. Okay, that's it. I hope you guys are getting good at this. You are going to have one problem like one of these problems on your next test where I give you one thing and ask you several questions about it. And you'll probably have to be able to use any of these kind of questions or fair game that have been talked about here. And units are going to be important too.